And now let's write the time functionality inside the LED blinker so we can make the LED blink without using the delay function. This functionality is actually the main specificity of this class, okay? So we have prepared the class with everything we need. We have the LED, we can initialize the LED. We have the toggle function ready to be used. So now let's implement the actual blink. So to do this, I'm going to add two new private attributes here. So let's put them here. Unsigned long, so in the LED blinker class, last time blinked, and unsigned long blink delay. So I will need to keep the last time we have blinked the LED and also the blink delay. So with this, we can make sure that we don't blink the LED or we don't toggle the LED before the blink delay has passed. So the first thing I'm going to do with those two attributes is to initialize them in the constructor. Okay, so last time blinked, I'm going to initialize it to millis. And we are going also to initialize the blink delay. So let's say that the default blink delay will be 500 milliseconds. Now the thing is that maybe you want to provide a different blink delay. Okay, we are not going to just create an LED blinker class, so we are blinking the LED at 500 milliseconds for any LED. Okay, we want to be able to choose when we create the class. So when we call the constructor, when we create an object, we are going to be able to choose the blink delay if we want to, or if we don't want to, we are just going to use the default one. So what I'm going to do, I'm going to add another constructor, so another overload of the constructor. Okay, so we provide the LED first as a reference, and then unsigned long blink delay. So I give an opportunity for the user who is going to use the class to also provide the blink delay when they create the class. So now I am going to also need to implement this constructor right there, LED blinker. I put the namespace and let's initialize this. So we still have this LED is equal to LED. We still have last time blinked is initialized to millis. And then what I'm going to do, instead of doing blink delay is 500, I do this blink delay is equal to blink delay. As simple as this. Okay, and now back to the interface. So I have my constructor, I can initialize the LED, and now I'm going to create a new function, a new method named update. So basically, how are we going to implement this time functionality? Well, with the update function, in the update function, this is kind of using the loop function. Okay, in the loop function, you are going to call the update function very fast, okay, as fast as you can without using any delay. And whenever you use the update function, whenever this function is called, it's going to check the time. So with the last time blinked and the blink delay, it's going to check the time, and if enough time has passed, it's going to toggle the LED using this private method here. Okay, so you are going to better understand when we implement the function and make it work. But basically what you do here is you kind of export the functionality you would write here in the loop. So the functionality to not use the delay, okay, to toggle the LED every X amount of time, you are going to export this from the void loop to the void update method in the LED blinker. And actually this, so I'm calling it update. You could also call it loop if you want to, okay, but I keep it as update. And well, anytime you have a class, like for example, a controller for a motor, a controller for anything, and that you need to basically call a function very fast, okay, to update the output depending on the input, for example, then creating an update method and calling it very fast from the loop is usually the best thing you can do. So now let's implement this void update. I'm going to go here, void LED blinker update and curly brackets. what do we do here? It's quite simple actually. If you already know how to use the time functionality, unsigned long time now. So we get the current time with millis. Why millis? Because we also use millis here and here. So be consistent. If you use micros everywhere, for example. And then if time now minus last time blinked, which is the attribute here, is greater than blink delay, in that case, what we do, so we do two things. We update the last time blinked. I'm going to update the last time blinked to time now to make it simple. And I'm going to simply call the function toggle LED. And that's it. We are done with the functionality. So that's very few lines of code now, as you can see, for the main functionality of the class. So what did we do here? So basically the update, keep in mind that the update is a function, is a method that you are going to call very fast in the loop function of your Arduino program, okay? That's not something that you are going to call from time to time. Just call it as fast as you can in the loop. So this is going to be executed again, and all over again very fast, right? So every time we check the time now, we get the time now with millis. We check, so the difference between the time now and the last time that we have blinked the LED, this is a duration that we check against the blink delay. So if the blink delay is, for example, 500, we make sure that we don't enter this if 500 milliseconds haven't passed. Once this is greater than a blink delay, so the duration is greater than 500 milliseconds, for example, we enter this block of code and we reset the last time blink to time now. So now we have to wait another 500 milliseconds to enter this if again, okay? And so if we enter this if, we also toggle the LED. So we call the toggle LED function. So we go here. This is going to call the toggle function from the LED object. So we go back to the LED.cbb, and the toggle is going to call is powered on, which is going to check the state. And then if it's powered on, it's going to call off, which is going to use digital write. Else is going to call on, which is going also to use digital write and update the state. Okay, so as you can see, the functions and the methods are very small because everything is kind of atomic. Okay, one method is doing just one thing. That's the way to write clean code. So now let's see what we have as an interface. The interface is really simple. Okay, we create an LED blinker by passing an LED, and if we want a blink delay, which is optional here because we have another constructor without the blink delay. And then we can call the init LED if we want, if we haven't initialized the LED before. And then the only thing we need to do is to simply call update in the void loop. So I'm going to go back to my main program here. I'm going to leave it like this, okay? I'm going to use the constructor, this one, with the default blink delay, okay? And now I have init LED, and I'm going to remove that, and I'm going to do LED blinker dot update. And that's going to do the same thing as the previous code we had here. And now, well, let's upload, first let's verify the code, make sure we don't have any compilation error, seems to be good. And let's upload the code to the Arduino. And you can see here the red LED on pin number 11 is blinking every 500 milliseconds. So the program is working. And if you look at the main file, we just have 15 lines of code to make an LED blink without using the delay functionality. Okay, and the code is super simple to understand. Okay, so you include the different classes, okay, and then you create an LED object, you create an LED blinker object from the LED, and then in the setup you just do init, and in the loop you do update, and that's it. That's really all there is to it. Once again, all the difficulty is hidden inside the implementation files, and you have a clear interface here, public and public, that you can use in your main file to make your programs very scalable and very easy to read.